Impact resistance is the energy used to break a sample using a shock load as an impact test. It is its indication of the hardness of the material. The soft impact test is a ASTM standard method you use to determine the impact resistance of the materials. The arm swings down, hitting the notch sample, breaking it, and then the energy that is absorbed by the sample, it is calculated by the arm, and the force that it hits it, and then you determine the impact energy and the notch sensitivity.
So the Charpy impact test was a test developed by George Charpy at the turn of the 20th century. This is a test that allows to know how much energy a material will absorb when it is impacted. The absorbed energy is useful because it allows us to let us know at what point the material will fracture. This test is very cheap, or it is used widely because it is very cheap and it is very easy to conduct. So it's an alternative to the ISAT impact test. The only thing that is a bit wrong in the test, or that is a bit different, is that it could only be used to set a comparative point between different materials.
The ductile fracture begins with the formation of the neck and the formation of the cavities with the strangulation zone. This fracture occurs by an intense deformation, and it is plastic. The fragile fracture have place in a deformation, a quick deformation by a rupture. It normally occurs when the tension is applied perpendicular, and also it happens in a low and a high temperature.
The applications of the impact test were first used during the Second World War, when the engineers in charge of the ships wanted to know what the fracture point of the ships was and to understand better the material that they were working with. So the current applications of this could also be for the ship testing, and could also be for other materials that we use that we know will have a certain impact at some point, or that we need to withstand a certain impact. Like it could be with the cars, in case of a crash, we need the materials to be able to withstand a certain impact so that the car doesn't turn into a complete mess after it is crashed by something else.
Well, in order to test the impact resistance of a piece, you need a pendulum, like this one right here. First, you need to, assure that it's aligned to zero, that it's all the way to the other side, so the measurement is correct. The pendulum calculates the force that the material absorbs by the differences of the height when the pendulum returns. First, as I said, you put this one right here, and you put the piece, you secure it in the location. You take out the safety, and you just let it go. And that's how you test the impact resistance.
These are the results for steel 1018 and steel 1045. In 25 degrees, we had the absorbed energy for the 1018. That was 54 pounds-feet, and it was ductile. And for steel 1045 in 25 degrees, the absorbed energy was 71 pounds-feet, and it was brittle. And in minus 11 degrees, for steel 1018, the absorbed energy was 8 pounds-feet, and it was also ductile. And in steel 1045, the absorbed energy was 24 pounds-feet, and it was brittle. So the transition point in a material is when a material goes from brittle to ductile. This is when it's brittle, it's because at less temperature it absorbs less energy. And when it goes to ductile, it's when the temperature is higher and it absorbs more energy. The impact test also taught me that the temperature in a material is very important at the moment that you want to do the test, and also at the moment that you want to manufacture with that material.
The impact test is very useful because it allows us to know how a material will behave after being subjected to a certain temperature or situation. Thanks to this test, we can avoid situations like the infamous Titanic case.
It's fundamental that we know the impact hardness of a material, well, the force that a material absorbs, because almost every machine applies some force to the material. For example, a piston, and you don't want your machine or your engine to break down in the middle of the process. So you must know at which force the material will yield.
For my conclusion, for any design you're going to make, you need to know the properties of the material you're using so you can avoid any accident.